Hello, my name is Jack Carville, and I was a member of the 21st Century Hammond Organ Team, which was sponsored by Arts Engine, and the faculty mentors were Dave Greenspan and Kyle Snyder. I personally did some additional work with Professor Austin Brenneman with regards to prototyping, which you will see later in this presentation. I am currently a senior studying mechanical engineering. So, what is the problem? What were we asked to do as a team? So we were asked to bring the Hammond organ disassembled below into the 21st century. And so as a team, we had to figure out what that meant to bring it into the 21st century. In turn, we as a team spent time just going through ideas as to what's a modern technology that is now pervasive that wasn't necessarily pervasive a year ago or a decade ago or a century ago. So we decided to make it playback, just be capable of playing back music and being accessible through that. How this was done was by implementing a mechanical MIDI playback system. This would take MIDI, a common file format for storing music, and interpret it into the correct keys necessary to play the piece, and then mechanically pull them down. Next, a member of the team, or a sub-team, designed and coded an app which would convert a drawn picture, seen here, into a MIDI file which could then be sent to the organ. This was to make it more accessible so that it was not necessarily for someone to know how to use an organ before they could play the organ. In addition, a test stand was built so that future teams would have an idea of how much space they have available to them before they start fiddling with things, and also to help the current team to get an understanding of the physical dimensions of the space, so that we weren't just working off of drawings and the disassembled pieces. Why is this important for future teams? Well, you see, now this organ accepts MIDI input. So regardless of how you want to send that MIDI input, you can, and it can accept any input as long as it's in that format, vastly increasing the ways that it can play back. And while the mechanical playback system has been implemented, it's still subject to further optimization if need be. Finally, we provided an open-ended framework for the future teams to work with, such that they can go in their own direction and decide how they want to implement the 21st century organ and how they want it to look. Now, in addition to this work, I also worked with Professor Austin Brenneman, again, to go through the prototyping process and just learn more about that. Now, the prototyping process, to really break it down into its core components, involves determining what design parameters you want to know about, running tests in order to isolate those parameters if you don't know them, and just identify the best ones. And then using those test results, figure out which one is the best for your particular application. In this case, most of the modeling was done towards solenoids, as we wanted to have a way to actuate the keys, given that an electrical playback method just hadn't worked. So I started out this process by just taking a first principles model, the equation used to predict the force of a solenoid, plotting it into MATLAB, and it failed. It failed horribly. The first principles model gave a predictive force that was orders of magnitude lower than the force I had from empirical data sheets, and in addition, reacted strongly to changes in voltage, which just wasn't seen in the empirical data sheets, as commercial solenoids tend to be isolated for that particular purpose. Next, we took this data from the empirical data sheets provided to the solenoids and graphed them into the objective space. So what we were looking at, the power and the force, and identified the Pareto curve, which is the solenoids that performed the best in this particular case, having the most force for a given power or the least power for a given force. This allowed us to scale down the decision space from all of the solenoids I had data on to around 4 solenoids that were actually in consideration. And once I had identified those, I could look at to see if there were possible identifying trends within the design space. So in conclusion, I was able to take this prototyping work to identify a best solenoid. However, by that point in time, the team had already picked one that worked, which identified another flaw in the prototyping process. Namely, if you're not doing it the quickest way, time is also a cost, and it's something to keep in mind. Now, as to how I got involved in this project, simply I went to the MDP fair last year and went around to a bunch of the tables, saw what was interesting, and applied, and then reached out to professors in order to get involved in taking this a step further to use as my capstone project. The biggest hurdle, obviously, was the virus, which meant that it was difficult to work on physical aspects of the project, such as building that test stand, or getting materials for the test stand, or finding a space to build the test stand, which just complicated my job immensely overall. And as a result, I spent more time focusing on the logistical side of the project than what would on paper be my main task, which is building the test stand. Finally, the project will be continuing next year, and I know there's already a team, though the project sponsors have asked us not to get in contact with them yet, and I have limited information on who is on the team. However, I would imagine that this team can go on and build off of the work we have done thus far to implement the MIDI, implement the playback, and to begin the casing and just generally begin outlining in exterior design now that the interior design has been finished. Thank you, and this concludes my presentation.